Welcome to our tutorial on using digital certificates in Java. In today's video, we're diving deep into the world of digital certificates and how we can utilize them within our Java applications for secure communications. Let's get started. First, let's understand what digital certificates are. A digital certificate is an electronic passport that allows people, computers, and organizations to exchange information securely over the internet using SSL, Secure Socket Layer. These certificates are issued by a trusted entity known as a certificate authority, CA. Digital certificates contain various information, including the public key, the identity of the certificate owner, and the signature of the certificate authority. This information is crucial for establishing a secure connection and verifying identity. To get started, we need to import a few libraries in our Java application. The most important library is the java.security package, which provides classes and interfaces for security operations. We'll also utilize classes from java.security.cert for handling certificates. Next, we need a digital certificate to work with. If you don't already have one, you can generate a self-signed certificate using the Java Key tool, which is a key and certificate management utility that comes with the JDK. Here's a command to create a key store and generate a self-signed certificate. Open your terminal and run the following command. This command generates a key store file named mykeystore.jks, containing a key pair with a validity of 365 days. You will be prompted to enter details like your name, organization, and password. Now that we have our self-signed certificate, let's load it into our Java application. We will create a method to load the key store and retrieve the certificate from it. In this method, we first create a key store instance and load our key store from the specified path using the provided password. We then retrieve the certificate using the provided alias. Let's go ahead and implement this in our main method. We will load the certificate and print out some details about it. When you run this code, you will see the details of your certificate printed to the console. It's essential to verify that the data printed corresponds to what you entered when generating the certificate. Now, let's utilize the certificate for secure communications. We'll establish an SSL connection using the Java Secure Socket extension, JSSE. First, let's create a method to set up an SSL context with our key store. In this method, we load the key store and initialize a key manager factory, which manages the keys in our key store. Then, we create an SSL context and initialize it with the key manager. Now, we can establish an SSL connection whether we want to create a server or a client. Let's implement a simple SSL client that connects to a secure server using the SSL context we just created. In this method, we create an SSL socket from the SSL socket factory, then initiate the handshake. This is where the SSL/TLS protocol exchanges keys and verifies the certificates for secure communication. For this example, you'll need a running SSL server to connect to. If you don't have one, you could create a simple SSL server using Java. This server will listen for incoming connections and respond securely. This server will continuously accept connections on the specified port and perform SSL handshakes when a client connects. Make sure to run the server before initiating the client connection. Once the client and server are successfully connected, you can exchange data over the SSL connection. You can implement your custom protocols for data exchange, ensuring the security of transferred data. Now that we've learned how to use digital certificates for secure communications, it's essential to understand how to handle certificate validation. This step ensures that the certificate presented by the remote entity is valid and trusted. In this code snippet, we validate the certificate by checking if it is still valid. You can extend this method to perform additional checks, such as confirming that the certificate is issued by a trusted certificate authority. In conclusion, using digital certificates in Java is straightforward. You can load certificates from a key store, establish SSL connections, and validate certificates for secure communication. The principles of security in your applications are paramount. We encourage you to experiment with the code snippets provided today. Try extending the functionality, create your own secure communication protocol, and enhance your understanding of digital certificates in Java. If you enjoyed this tutorial and found it helpful, please give it a thumbs up. Also, subscribe to our channel for more programming tutorials like this one. We'd love to hear your feedback and questions in the comments below. Thank you for watching, and we look forward to seeing you in our next tutorial. Stay secure.